Central processing unit that we call in the short form CPU. What is the role of the central processing unit? How it is going to communicate with the control memory, main memory with the help of processor, how it's going to perform the various tasks. So that discussion will be here in this, it is separate chapter actually, okay? But as per syllabus, it is kept in the particular syllabus in the unit 2 itself. So to cover this center processing unit, it will take almost 4 to 5 lectures. Okay. And before this, we have lecture for the microprogram control that you can see in the playlist. Inside this first topic, we are going to see that is the general register organization. So here, earlier we have seen that transfer register to register, or you have seen the RTL. So here actually we are going to see the actual role of the control memory unit. How that word contents of the control memory is going to control this entire address sequencing and all that we are going to see here. So your concept will be much clear again here with different examples here. So still, if you didn't subscribe our channel, please subscribe it and share with your friends. Okay, let's start with the general register organization. If you have any doubt, keep on writing in the comment. Okay. So name is what here? General register organization. So we are going to talk about the general registers, that registers are associated with the processor. How those registers are organized here to perform this some particular micro operation. So that CPU is central processing unit that performs the bulk of data processing operation. We have seen that even within a second, within a millisecond, how much information we are able to obtain. And if you talk about the space communications, so within the fraction of the nanoseconds, what things are going to happen. So it has three major parts. The first one is the register set store the intermediate value. Okay. So during the execution, some intermediate value, what we need, we can store here. Always we are not going to store in the memory. So to store in the memory, again, you have to seek for the particular address, at which address we are going to store. So all this we going to take the time. So that propagation delay is going to occur. So we have some intermediate that you can say that processor registers are there that going to store the intermediate data or temporary data. And this ALU is the arithmetic logic unit that performs the required micro operation, whether we have arithmetic micro operation or we have logic micro operation or we have shift micro operation. All these things, okay. So mainly ALU is the arithmetic logic, but along with ALU we have arrangement for the shift micro operation also. And entire this activity is being supervised by the control unit. So already we have seen the role of the control unit, that we have separate control memory that having control at its register, and that is the word having particular size as per the system that is going to control the other operation in the system. So it is more efficient to store the intermediate value, okay, in processor registers that we have seen already in compared to memory. And it is most efficient to connect with the common bus. So bus is what? It is the collection of the wires that provide the path between one to another. So we can have one register to another register. Okay. So for that, we are having the common bus system we have seen earlier. So for that separate lecture is there. You can see that. So overall, finally, CPU having control unit, register set, and arithmetic logic units. So now here, right side, we are going to see that how this control unit is going to help to perform some particular operation here. So here, if you see that here we have 7 registers are here, R1 to R7 here. And it is whenever we have register is designed with flip-flop, so their clock is required. So clock pulse is here. And here we have 2 multiplexer one multiplexer is connected to the bus A, another multiplexer is connected to the bus B. So that multiplexer A is also connected with all registers and multiplexer B also connected with all registers. Apart from this, input is also this input, what data input, whatever we are going to give, that is external, that is also connected to the both multiplexer A and B. So finally, both multiplexer will have now how many inputs are here? So here total now 8 inputs are available to both multiplexers. So when multiplexer having 8 inputs, so how many selection lines will be there? That is 2 to the power 3 cross 1. So number of selection line is what? 3. So for the multiplexer A as well as multiplexer B, what we are seeing that we have 3 selection line. For the multiplexer A, it is the selection line A. For the multiplexer B, it is represented by the selection line B. So as per the combination of, next we are going to see that how we are getting this value of the selection line A and selection line B, that we are going to see. So actually it is coming from where? From the word of the control memory. In the previous lecture, if you see, we have seen taking the word size of 20 bits in case of control memory. So that this 20 bits having different roles. Okay. That where we have 0 to 6 was for the address, 2 bits for the branch, 2 for the conditions, and 3 bits each for the F1, F2, F3. So total 9 bits are given there for the micro operation. So there was the total 20 bits. Here the control unit, what example is taken for that word size is 14. So when word size is 14, out of this 14, that taking here 0 to 4, that 5 bits is given for the operation. Next 3 bits are given for the selection line A. Next for the selection line B. And next for the selection line D. So total how many we have here now? 9 plus 5, 14. Here 3, here 3, here 3. And for the operation we have 5. So total we have 9 plus 5. That is the 14 bits register is taken. Here means that word size is of 14 bits. That we'll see again in detail. So out of that, this 5 is used here for the operation of the ALU. On the basis of that, what are the combinations? That is going to decide ALU is going to perform which operation. Similarly, selection bit combination is going to select which register is going to be the input that will be available to the bus along with the here external input. So that which information or which content will be available on the bus, that is decided by the concerned selection line. Again, here you are seeing that output of the ALU is connected to the registers inputs. So when registers will be loaded, that is being decided by the decoders. That is the 3x8 decoders are here. So this decoder is going to decide which register should be loaded. So on the basis of combination of decoder output, which output is high, on the basis of that particular register will be loaded with the data if clock pulse is available. Like it is the how in general this control unit is going to control this operation. Now same thing here. Again you see that if their visibility is not proper, you can see in this portion also. So here in this part, it will have here, see later we are going to see here how these bits are arranged. Okay. So total 14 bits. Control word is considered here. Total how many? 14 bits. So that word is stored where in the control memory. That's why we can use the word control word for the better specification. So control word of the size 14 bits are considered here. So this multiplexer selection line select one register, one input data that depend upon the selection line combination, and that is available to the bus A and B, and from bus A and B it will be given to the ALU is the arithmetic logic units. So there we have data registers and we have accumulators. So that is going to perform the micro operation. The contents of the accumulators and contents of the data registers or the contents of the register itself is going to take part in that ALU. So from bus, suppose for example here in this case, we'll have only register. Suppose later we'll have example there also. Suppose A bus having register 2 and B bus having register 3. So finally between this register R2 and R3, any arithmetic or logic operation will be performed. Sometimes like for the increment, decrement, clear and all, only one bus output is sufficient, another bus output will be 0. So that selected operation determine the which micro operation will be performed. Okay, here again, here you are seeing that operation 5 bits are there. This 5 bits combination is going to decide which micro operation will be executed by the LU. And result of micro operation is given to the register. So when register is going to be loaded, that is going to decide by the decoder. So arithmetic, logic, and shift operation, all three are performed with the help of ALU or CPU. Anyhow, CPU is the main thing that having you have seen the control unit is there, register is there, all these things combinations. The operation of the control unit here, that control unit's name is the control. It's going to control the flow of the information. So selecting the various components in the system, selecting the function of the LU. So which components will be loaded, which component is going to throw the output on the bus, which component is going to take input from the bus, and LU is going to perform which type of the micro operation. All these things is taken care by the control unit on the basis of their bit combinations, which is available in the word. Now one example is taken here. If system want to perform the addition of two numbers and want to store in the another registers. So R2 is the contents of one data, R3 having another data. These two should be added and it should be stored in the R1. So this is RTL, register transfer language, where register followed by decimal number is going to give the notification or representation of the particular registers. Multiplexer A will be selected by the selection A. So here R2 contents will be transferred to the bus A. In the mux B, selection B, R3 will be transferred to the bus B. Now bus A and B having contents of the augment and addend. And finally, this operation will be takes place in the ALU with the help of A plus B. Now output of the ALU will be stored where in which registers that being controlled by here. So that decoder destination selectors. So that selection D is the input to the decoders. So finally it will activate the register R1 so that it will take data from the out bus. Now here actually finally you can see it is the 14 bits word of the control memory. Operation is 5 bits and each selection having 3 bits. So now here when it is 00, nothing is going to happen here for the binary codes. So for remaining 7 combination, by the 3 bits total, how many combinations are there? 8 combinations. So 0 combinations is not useful here. Only remaining 7 combinations are used. So when it is 001, okay, so what is be the selected by this SLA will give the R1. So SLA is connected to the mux 1, okay, or we can say the mux A. SLB is the responsible for the mux B, and cell D is responsible for the decoder. So finally, here, if situation is here, binary code 001. Port is shown for the all. If cell A is also 001, then it will select R1. Cell B is also 001, it will select R1. And cell D is also 001, it will give permission or it will make active R1 to be get loaded. So like this in different situation, we have different combinations. Okay, but this table you have to take care. So it is the on the basis of the decimal equivalent, here suffix you can consider. Like it is 1, so R1. It is what? Decimal equivalent 2, so R2. 3, 4, 5, like here 7, so R7. So for the particular, suppose for example, we are taking that for the cell A, its combination is 001. Cell B combination is suppose 011. So now it is what? 1. It will select the R1 registers. It will select the R3 registers. So bus A will have R1, bus B will have R3. And here cell D having suppose 100. That means R4 will be loaded. Okay. So like this combination is there. So here that is written clearly. 3 bits of cell A, select the source for A input of, so this is the bus A. 3 bits cell B for the bus B, that is going to be input to the LU. And here selection D, 3 bits for the destination, that is connected to the decoder. So cell A, cell B for the bus A, bus B, that is the source. Cell D is the destination where contents or output of the LU is being stored. And this 5 bits of the OPR operation is going to decide any one of the operation. Okay. So here we have 5 bits are there. So total 5 bits, how many combinations we are going to get here? Okay. So total any of this 12, 11 operation, anyone will be performed. So like here we have this 00, all bits are 5 bits are 0, it will transfer the information. Okay. Transfer of A. 1, A, increment of A, like 2, addition of A plus B. So when this addition, we have seen earlier, addition takes place. So that time operation bit should be 00010. That is connected to the ALU. Then only ALU will perform the addition. So like this, so only 11 combinations are being utilized to perform the various operations, subtraction, decrement. So when decrement, increment is there, only one bus is enough. So that only one multiplexer is going to give the output. Logic AND, OR, XOR, complement. So for the complement also, only one bus is enough. Shift right, left, only one bus is enough. So one multiplexer is going to give the output. So now further, much detail about this example parts here to understand the operation. So here subtraction is taken as example. We want to perform the subtraction between the contents of the register R2 and R register R3. That should be stored in the register R1. Okay. So any doubt is there, you can write, okay, in the comment box. So this R2 we have to obtain from the bus A, and this R3 we have to obtain from the bus B. So according to this, that selection line of bus A, what should be the selection line of this multiplexer here, which is connected to the bus A? So here you are seeing that it is the register R2. So what will be the 010? This is the R3. So what will have 011? So this is the selection. If you see in the diagram, selection B, this is the selection A. Now this 2 should perform the which operation? Subtraction. So for the subtraction operation, here we'll have 00101. Okay. And it should be stored where? In R1. So R1 is what here? Destination cell D. For that combination should be 001. So that's why here you are seeing that this is the cell A, this is the cell B, this is the cell D, and this is the operation. So this cell A, first we need to write on the basis of this. Okay. So starting from here, cell A, cell B, cell D, and operation. In case of 20 bits, what we have there? F1, F2, F3. After that, we have CD, BR, address. Okay. So this F1, F2, F3 is starting from the left. Similarly here, you can keep in mind A, B, then D from the left side. So finally, for this operation, these are the combination of the control words, these 14 words, what we are going to obtain from this control word of the control memory, that is going to decide which type of the operation will be performed. So on the basis of this control word combination only, system is going to decide. So that control memory is going to control this completely, this address sequence, the data, which operation. So that is done with the help of control word. So now here for the logic or operation, what are things are required? Register R4, R5. Again, it should be stored in the R4 only. So that's why cell A is the decimal is 4. Cell B is the 5. It should be stored in the 4. So cell D is the 4. And for the micro operation combination should be that operation bits 0, 1, 0, 1, 0. Okay. So like this, all other operation takes place here. So this combination, how we are writing for the, it's easy to write for the cell A, cell B, cell D. But for the few operation combination of these 5 bits, you can, by practice, you automatically will able to remember. So finally here, in this topic, we have seen how this CPU is going to play the role, and by the help of this control unit, by the help of this control word, how we are able to perform the various arithmetic, logic, and shift micro operation. Okay. Any doubts is there? Please write in the comment box and like, share, and subscribe. Thank you. Thank you.